indexing. The first element is in the index 0, second element is in the index 1, okay, third element is in the index 2, fourth element is in the index 3, and fifth element is in the index 4. Okay, if I have to print, if I have to access the elements, so I am going to run a loop, okay, like this. For I is equal to 0, I less than 5, and I plus plus. Okay, I want to access all the elements. I perform something like this. Now what happens is, I'm going to add one printf statement here. Percentage D equivalent of ARR of I. It represents the value 0 first. ARR of 0 gives me 10. ARR of 1 gives me 20. ARR of 2 gives me 30. Like this we printed the elements of the array. But this time I don't want to print it using the main function, because many times I have to print the elements of the array and I cannot keep writing the logic again and again. Okay, the logic cannot be written again and again. It is waste of time to have the same logic written for multiple times. So what I want to do is, I want to access the elements being inside an other function. Okay, so I want to access the elements being in another function. So I am going to call a function called display. Okay, let me call a function called display. Now to this display function, I will pass the base address of the array. Okay, to the display function, I am going to pass the address. When I have to pass the array, I just have to pass the starting address, because all other elements are continuously sitting one after the other. So I have to pass the starting address of the array. Okay, starting address of the array. Then I have to tell the number of elements inside that array. Do you people know how to get the starting address of the array? Yes, you can either write address of ARR of 0, or you can just write ARR of ARR. That is also enough. Okay, just the name of the array will represent the starting address of the array. Yes, you can either write address of ARR of 0, or you can just write ARR of ARR. That is also enough. Okay, just the name of the array will represent the starting address of the array. Okay, you don't want ampersand of ARR of 0. So you just want the name of the array, because it is saved by a pointer variable, which is an integer pointer. Okay, so the 1000 what you are passing here can be received by one integer variable, integer pointer called ptr. Then I am going to pass the size, which I am going to collect it into one integer variable called size. Okay, so I am just passing the name of the array, which represents the base address. I passed 5, I collected into a integer variable. Now I want to print all the elements. So just like what we wrote there, I am going to take one integer variable called I, and here in this case I used to write ARR of I. ARR is the name of the array representing 1000. Now who is representing 1000 for me in the display function? In the main function we used to write ARR of I. and ARR was representing the address 1000. Now who is representing 1000 for us? It is PTR. So we can write PTR of I. Okay. In order to access the elements, we can write PTR of I. And instead of me running the loop for 5 times, I will run the loop for size number of times. Okay. Why to hard code? I know how many elements I have inside the array. I am going to run for size number of times. Okay, so that is how the pointer is considered. So I am calling the main function. Okay, I have integer array ARR of size 5 with certain values. I want to access the elements. I am calling the display function. I pass the starting address and the value 5. 5 is telling I have 5 elements inside my array. So I pass the base address, I collect it into a pointer. I pass the size, I collect it into one integer variable called size. I'm running the loop. Here to access the array's elements, I would write ARR of I. ARR was actually representing 1000. So it is 1000 of 0, 1000 of 1, 1000 of 2. That is what we used to do. Now the same 1000 is represented by a pointer variable called PTR. So we are writing PTR of I. Okay. So this is functions call. This is functions definition. So when you write the functions call before functions definition, then you have to write one functions prototype. Okay. It is mandatory to write one functions prototype like this. Functions prototype is nothing but the very first line of your function terminated by a semicolon. So that is the shortcut you can remember. Okay. While passing ARR in the main function, it is not addressed right. It is addressed, Harish. As I said, ARR is having a special meaning. The name of the array always represents the address in which the array is found. Okay. So Kalyan Satvik is asking PTR of I can be written as star of PTR plus I. Yes, Kalyan, you can. I don't want to confuse others with that concept. So I'm just keeping it simple. Okay, so that is how we are going to perform the operation. I hope you have understood it. So that is passing array. So here it is actually a pointer. Okay, int ARR is the pointer. Okay, Arvind is asking why ARR and why not ampersand of ARR. Ampersand is not necessary because as I said, name of the array will represent the starting address. So you don't have to use ampersand again for it. Okay. So Vinay is asking why prototyping, which is specify the arguments type is enough. Yes, you can either specify only arguments type or you can specify that along with arguments name also, which is fine. Okay. So Deepika is asking, why don't we write star of PTR of I? Okay, I'll explain that. What star of PTR of I does. Okay. Now see, what happens is, I'll put this down. This is our display function. In the display function, we have two variables. One is a pointer, the other one is a size. So this is our display function. I have two things. One is the pointer, the other one is the size. Okay. So now the pointer, when I pass ARR, please remember this. It is just the name of the array who represents the starting address or the base address of the array. So I am passing ARR, which is the base address or the starting address of the array, 1000. Pointer receives 1000 and your size receives 5. Okay. In the main function, when you write ARR of I, so this used to give you 1000. ARR represents the base address 1000. Internally, it is 1000 of 0. It is 1000 of 1. It is 1000 of 2. It's like this, 1000 of 0. It is 1000 of 1. It is 1000 of 2. Okay. So that is how you did inside the main function. Now, I don't have ARR in the display function. Instead, I have PTR who is representing 1000. So, in order to say 1000 of 0, 1000 of 1, 1000 of 2 in the display function, I should write PTR of 0, PTR of 1, PTR of 2 and so on. Okay. Just I am trying to correlate. PTR is 1000. 1000 of 0. Okay. You will go in 1000 you go index 0, you get 10. From 1000 you go index 1, you get 20. From 1000 you go index 2, you get 30. So it is 1000 of 0, 1000 of 1, 1000 of 2 and so on. Okay. Now what happens if you write star PTR of I is star of 1000 of 0, let's say. So 1000 of 0, this is 1000. 1000 of 0, you already have 10. So you are writing star 10. 1000 of 0 is already giving you 10. So you are writing star 10. Star 10 is wrong. So this gives you segmentation fault. Okay. You should not be doing it. So that is how you are going to perform pass by reference by passing the array as an argument to a function. I hope you people understood this, right? So that is the program here to print the elements of the array. This see it as a pointer. So this is nothing but int star. Okay. So think it as a pointer here. Next one. How to return the array from one function to another. Okay. So how do you return an array from one function to another? Now see what happens. I have an example here. Okay. First, this is the main function. So I'll take the main function here first. Okay. I'm explaining the code how this is running. So this is our main function. So in the main function, I'm performing certain operations. Okay. This is my main function. My main function is having an array called array of size 5. This is main function. So this is having array of size 5. Okay. I'll copy this. It is an array of size 5. Okay. Then apart from that, I have one integer pointer called IPTR. This is my integer pointer IPTR. It is ready to store some address. Okay. This is IPTR. It is ready to store some address. Okay. Now I am calling the modify array function by passing array and 5. Can you tell me what gets passed here? To the modify function, what gets passed? So when I pass array and 5, array is the name of the array here. Okay, so it is ARR. Array is the name of the array here. So it actually passes 1005. Okay. Then I collect it into modify array function. So I am collecting it into modify array function. Now in the modify array function, okay. Now here in the modify array function, I collect it into two things. One is a pointer variable. This is the modify array function. Modify array. That is the name of the function. So in this, I am taking one pointer called array, one integer variable called size. Okay, this is my pointer array. Array, I am just keeping the name same. Okay, and this is size. Array is a pointer in the modify array function. This is size. So array receives 1000 here. Size receives 5 here. Okay. Array receives 1000 here and size receives 5 here. After this, I am going to write star array plus I plus equal to 0. Star of array plus I is nothing but array of I. Okay. So instead of me writing it like this, let me tell you, array of I is same as star of array plus I. Okay. Array of I is same as star of array plus I. Okay. Now what happens here? Instead of this, I'll write it as array of I. Plus equal to, you already know, I'm going to change it. We have already studied array of I plus equal to 10 means array of I is equal to array of I plus 10. Okay. Now array inside the modify function is representing 1000. So I am writing 1000 of 0. I is 0 plus 10. What is 1000 of 0 giving me? 1000 of 0 gives me a 10. 10 plus 10 is 20. Where to write the 20? It is to array of 0. Means 1000 of 0. This is 1000. 1000 of 0 is changed with 20. Okay. Next. Array is still representing 1000. When it is 1, 1000 of 1 is equal to 1000 of 1 is equal to 1000 of 1 plus 1. So 1000 of 1 is representing me 20 plus 10 here. 20 plus 10 is 30. Where should I write that 30? It is to 1000 of 1. This is 1000. 1000 of 1, I have to change it with 30. Like this will be changed to 40. This will be changed to 50. And this will be changed to 60. Okay, this will be changed to 60. Now I say return array. Array is a pointer. It represents 1000. I return 1000. Okay. 1000 is returned. You collect it into a pointer variable called IPTR. So 1000 is returned here. IPTR receives 1000. Okay. IPTR receives 1000. After this, I am calling the print array function by passing 1005. So here I am passing 1005. So 1000 is collected by a pointer. Size receives 5. We are accessing the array's elements. We get 20, 30, 40, 50 to 60 printed. Okay, print array function is just like your display function. It is going to print the elements of my array. Okay, in fact, if you want, I can detail it. Okay, now I come back, I'm in the print array function. So this is the definition of print array function. So this is the print array function. Now what happens in the print array function is, this is our print array function. Inside print array, I have array and size. Okay, this is print array function. Print array function. So inside print array function, I have, let's say, array and size. Okay, so like this we have. So here I am passing 1000. Okay, I am passing 1005. So array here receives 1000. Array receives 1000 and size receives 5. So what I am doing is, I am printing 1000 of 0. Array is 1000. So 1000 of 0, I have a 20. 1000 of 1, I have a 30. 1000 of 2, I have a 40. Then 50, then 60. This is nothing but int star array. Array with an empty braces means int star array. Okay. So I am passing 1000 here. 1000 of 0, 20 is there. 1000 of 1, 30 is there. 1000 of 1, 40 is there. 1000 of 3, 50 is there. Then 60 is there. So that is how the elements will be printed. The output of this program will be 20, 30, 40, 50 and 60. Okay. So that is how you return the elements of an array. Okay, so that is about the returning array. Let us take a break of 5 minutes.